In the previous video, we were creating simple scatter plots. In this video, we're going to create a simple line graph. We can create line graphs by replacing our calls to scatter with calls to the plot function. Before we do this, we need to rename our line widths parameter, if you've used it, to just line width. So let's return to our code and make a line graph out of our scatter plot. We'll change .scatter to .plot. And again, if you're using line widths, this now needs to be line width. And if we run this code, we see that our chart is now a line graph. As always, we have further customizations. So we can specify whether we want dashed lines or solid lines via the line style ls parameter in our plot function. And we can adjust the size of our data markers using the marker size or ms parameter of plot. So let's try that. We can say our line style is equal to dashed for our second x-axis. And again, details about this is available in the matplotlib documentation. We can also adjust the size of our markers with ms. So ms, let's say, equals 10. And you can see our data markers are quite a bit thicker than our line. We can also use line width to adjust how thick or thin our lines are. We can have different dash types as well. So our line style could be a dash followed by a period, and then we have a dashed and a dotted line. So these are just some of the customizations you can make to your line graphs. Now, our current plot, we can see the trend of both our data sets over time. Both the smoking rates and lung cancer death rates decrease over time, don't they? Now, would the story be a bit easier to convey if we overlaid both of these data sets on top of each other with a shared x-axis and a secondary y-axis? One y-axis for our smoking rate and one y-axis for our death rate. Well, let's give it a try. Now, we've already been using the subplots function, but this time we're going to use it a little bit differently. We're going to use the twinx function to create a second y-axis that will be used for our lung cancer data, and we'll share the x-axis with our smoking data. So we're going to change our figure function. It'll have the following code. We're going to change subplots to remove 2, 1, and share x. We're just going to leave figure size. And we can get rid of this adjustment. We no longer will have the horizontal space between our two axes. Next, we're going to add our plot title, plot our smoking rates on the primary y-axis using ax.plot, and then we're going to add our y-axis label. So here's the code that we're going to use. And I'm also going to update the variable name axes to just be ax for axis. We'll pull our x-axis, our y-axis, and y-axis cancer data again. We're not changing this code. But what we are doing this time is we're going to plot percentage smokers. By calling ax.plot, we only have one axis this time. We'll pass in our x-axis, our y-axis data. We'll label this as percent smokers, and we'll keep this as a line. We're going to change axes bracket 0 to just ax to set our y label. We'll get rid of our grid lines for now. And because we have only one plot, we can change axes 0 to just plt.title. It's now time to create our secondary y-axis. So we're going to call the ax.twinx function to create a second y-axis. And then we're going to use the plot function as we did before to plot our lung cancer death rate data. So watch this. We'll create a variable ax2 and set this to ax.twinx. This gives us our twinned x-axis. And then we change this axes1 to ax2.plot, keeping everything else the same. We'll change ax2 set y label. We'll get rid of our grid lines for the moment. And then finally, we'll add in our x label. We'll add in our grid for the plot overall, and we'll call plt.show. Drum roll, please. And there is our data overlaid atop one another. Our lung cancer deaths per 100,000 on the y-axis, secondary, and our percent smokers on the x-axis. Now, which data represents which? Well, we can add a legend, plt.legend. And we'll make sure to put that in before the plt.show. Now, you may have noticed, we have a legend, but it only has the lung cancer deaths. Only the secondary axis is being displayed in the legend. If we want to build a legend with both our data sets present, we're going to have to make some minor tweaks. First off, we need to assign the results of each of our ax.plot calls to variables. We'll call this plot1 and plot2. So we'll say plot1 is equal to ax.plot, and this is our percent smokers. And then we'll do the same thing for plot2. So plot2 equals ax2.plot. We have both our plots. Next, before we call plt.show, we need to create a new variable called lines, and we'll set this equal to plot1 plus plot2. Then we need to create a new variable called labels, and this will be a list. So we use square brackets. And the way that this list is going to get built is we're going to call some special code. So we'll call l.get_label for L in lines. What this is going to do is build up a list of line labels for each of our data points. And then finally, we're going to take our plt.legend call, move it from up here to just under labels. We'll pass in parameters to the legend function. First, we'll pass in lines. Next, we pass in labels. And then finally, we can do plt.show. And now we can see our two data legends. So we've now created a line graph of smoking rates and lung cancer deaths over time, and better yet, we shared the x-axis and overlaid the data sets on top of each other to demonstrate a correlation between the two data sets.